Okay, welcome back. I'm just going to run through a quick example here showing how to solve polynomial inequalities. An inequality, in case you forgot, is when you've got greater than or less than, or in this case greater than or equal to. So h at x, normally we've been working with equals this sort of thing, and now we're looking at what happens when we've got the greater than or equal to sign. The first part here I'm going to go through fairly quickly because it's the stuff you've been working on. Factors. So our first step will be factor to find the zeros, and our possible factors, given the fact that there's a 2 as the first coefficient and 12 as the constant. All the factors of 12 are possible numerators. All the factors of the 2 are the possible denominators. And you see I don't have the plus or minus on the bottom numbers because of course we get duplication then. If I deal with +1 and +1, -1 and -1, that's actually still both. In both cases, that's the number 1. So I can kind of list them off just to make sure that I remember what they are. In the end, I'm just trying to find one that works. And so here I've tested x equal -1 and trying to determine does h at x equal 0. Run through it, and it turns out that -1 does not work. But +1 does. Okay, now again, what we're looking for when we do this is we're looking for the restriction. So I've determined here that x minus 1, when 1 works, x minus 1 is the factor. In synthetic division, though, I actually use the restriction. So I've gone through, solved it, and factoring this using an older method, basically looking for two numbers that multiply to 2 times -12 is -24. Looking for two numbers that multiply to -24 and add to 5. Or sometimes we use kind of a trial and error method. I've mentioned these in a previous video, so I won't go through it in too much detail, but these are the factors. And then in order to solve that, I'm interested in where does this thing equal 0? Of course, I'm looking for the zeros, so the zeros occur when x is 1, because this whole thing is 0 times whatever. When x is 2/3 here, or sorry, 3/2 here, because then this becomes 0, and -4 here, because then this becomes 0. Okay, so that's what you've been doing for a while. So we, again, won't go through that in too much detail. What I'm interested then is what do I do once I know those zeros? Okay, and so we have two options. One is to finish the question algebraically, and this will look a little strange, but understanding that my zeros are at -4, +1, and 3/2, it means that whatever this graph looks like, it's going to be positive or negative between those points. Okay, so the point -4 here is a key point for me. The point 1 is a key point, and the point 3/2 is a key point because those are the zeros. That means I'm going to be above that or below that in each of these intervals. And so if I'm looking at the algebra, I'm basically just going to look at each of those sections individually. Okay, so the value is less than -4. All of these values will be the same. They will all be positive, or they will all be negative. Okay, so when x is -5, -6, -7, the y value will be above 0 or below 0. And so just testing a value here, choosing -5 and plugging -5 into this original equation, I get that the y, is -78. So that means in this section of the graph, I will have negative values. Now, as far as writing this out goes, I guess I would leave out all of the blue stuff. This was just sort of for explanation purposes. This is what I'm going to actually end up writing, though. It's negative in this section. I recognize that where these lines are is where my zeros are. So my negative values, or once I've tested, I've determined that these are negative values. In the section -4 less than x less than 1, So choosing something in here, a nice easy one of course is 0. 0, 0, 0. I'm left with 12. And so all the values in this section of the graph will be positive. In between here, 1.2, 1.25, something like that. 1.2 is used here. And we get, again, a negative value. And then choosing a number greater than 3 halves, a number like 2, a number like 100. Obviously something quite large like 10 million would work as well. And we should be able to recognize I'll have a positive value there. Okay, now here we've got the exact answers in each case, but of course when you start looking at these, if you can determine the number as being positive or negative very quickly, it doesn't matter what the actual number is. As my graph gets out here, my x values get very large, and so I'll have something like 2 times, say, 1,000 to the exponent 3. Well, that's going to be much larger than any of the rest of this. And so right off the bat, I know that's a positive value. Turns out this is positive as well. Of course, I'm going to end up with a positive value then. So you do as much work there as you need to determine what those values are. And then basically we're just determining, sort of what I did here. Is this a section of the graph that I'm interested in? Well, no. I want the values where the graph is greater than 0. Or sorry, in this case, I used greater than or equal to when I rewrote the question. So in this section, is it greater than or equal to 0? No, it's not. In this section, it is. No, it's not. Yes, it is. And so, kind of finishing up, my final answer would be, okay, we do have a second option, and that'll essentially be to finish up by graphing. So we know the zeros are at x equals 1, 3 halves, and negative 4. So we would plot those points on our graph. If we look at this, two possibilities here. One is that we recognize right away that's a cubic equation, and it looks something like this. The second possibility is that we need to figure it out. We don't remember what the graph looks like, in which case we would do something like this over here, where we're just kind of thinking it through. What happens as x gets really small? So if I test a number like negative 100, I get negative 100 times negative 100 is 10,000, times negative 100 is negative 1 million. And so this number is getting to be extremely small negatively, or extremely large negatively, whichever way you want to look at it. The y values are approaching negative infinity. And so if I didn't know, I would recognize now that the graph is going to tail off down this direction. Knowing basically how the graph works, that's probably all I need, because I would then just kind of follow up through the 0, recognizing there's no double roots anywhere. I come back down, and again the graph finishes up. But if I needed to do a little bit more, think about the other side. What happens is x gets really large. Again, put in 100 or 1,000 or some number. We see this gets to be an extremely large positive value. This gets to be an extremely large positive value. This is a medium or a small, relatively speaking, actually negative value. And so the graph on this end is approaching infinity as well. Okay, so somehow, based on what we've done before, we can put this graph together, having seen where the zeros are. And then essentially we see exactly the same thing. In this section of the graph here, I have positive y values. In this section of the graph here, I have positive y values. And so this negative 4 less than or equal to x less than or equal to 1, and x greater than 3 halves are my two sections that I'm interested in again.